Good evening, sir. My name is M. Varshasri. I'm from Computer Science Engineering branch, and today I'm here to give a PowerPoint presentation on the topic of free cationic polymerization of the polystyrene for the subject chemistry, and the subject code is 23CHA01. Explain the free cationic mechanism of the polystyrene. The monomer styrene is obtained from the benzene and ethylene under the pressure at 90 degrees Celsius in the presence of a catalyst, and the resulting ethylene benzene is dehydrogenated to the styrene in the presence of the iron oxide or the magnesium oxide. When benzene is reacted with the ethylene in the presence of aluminium trichloride at 90 degrees Celsius, the ethylene benzene is formed. The formed ethylene benzene are dehydrogenated under the magnesium oxide and gives the styrene. For the free cationic mechanism of this polystyrene, we need the three steps: the initiation, the propagation, and the termination. To execute the initiation step, we need an initiator. The initiator in cationic polymerization may be the boron trifluoride, aluminium trichloride, titanium tetrachloride. Here we uses the boron trifluoride as the initiator. When the boron trifluoride reacts with the water, it forms the boron trifluoride hydroxide ion and the H plus ion. Here the H plus ion is used as the main ion in the whole polymerization, because the H plus is a cation. That is why it is named as a cationic polymerization, as the H plus is a cation. The initiation begins with the generation of a reactive cationic species, typically a Lewis acid. Common initiators include the strong acids such as the boron trifluoride or the aluminium trichloride. Here, the polystyrene, when reacts with the counter ion, that is the boron trifluoride hydroxide ion and the H plus ion, it the unsaturated bond is converted into the saturated bonds. In the mechanism of the initiation, we can see that the pi bond of the polystyrene is transferred to the carbon. Here, the pi is the donor, that is why it is formed as the positive charge, and here it formed as the negative charge. This will react with the H plus ions and forms the saturated bond in the product as shown. The second form and the second step of the polymerization is the propagation. The carbonatic species generated in the initiation step reacts with the monomer unit, forming a new reactive species. The reactive species can further react with the additional monomer units, resulting in a chain growth process. The product formed in the initiation step is again treated with the monomer polystyrene, and here the product is also formed as the unsaturated is converted into the saturated. In the mechanism, we can see that the double bond, that is the pi electron, is transferred to the another carbon, which forms as the negative sign, and the donor, which positive sign forms. And the double bond, which is an unsaturated bond, is totally converted into the saturated bond by forming the product as shown in the mechanism. The third one and the last one in the polymerization is the termination, where it is the final one which forms the final product of the polymerization, and important it plays an important role in the whole polymerization. In the mechanism, we can see that the formed product in the propagation is treated with the N molecules of the polystyrene. Here again the double bond, which is in the unsaturated position, one is totally converted into the saturated. That is, the pi bond is totally transferred to another carbon, which forms as the positive sign, and which accepts it forms as the negative sign. Again, which it transfers, then the whole reaction and the product forms the saturated, as shown in the product given below. So the cationic polymerization forms the unsaturated into the saturated one by using the Lewis acids. The Lewis acids in the polymerization, especially in the cationic polymerization, plays a very important role. The properties. Polystyrene is a light, transparent, and resistant to alkalis, oxidizing agents, etc. It is chemically inert. It is a very good electrical insulator. Polystyrene is used in the manufacture of a molded like the toys, jars, bottles, radio and TV parts, etc. Thank you so much for giving this opportunity to give a PowerPoint presentation on the topic of the free cationic polymerization of the polystyrene.